All right. Well, let's go ahead and take questions first. And then I got some general things I want to comment on based on questions I've been getting. But let's take questions first. On ODPs or PA1 or the meaning of life or whatever. Yeah.
So on yesterday's ODP, I finished it and I did all the test cases that were, well, no, there were like 3, right? I got 3 10s.
Okay.
I turned it in, and then out of 5, I got 1 0 out of 10. Is there any way to check the cases that were used when grading?
So that tells you that there's a test case that you didn't check somewhere.
I did the all test cases.
But what was your main program before you assessed? What sorts of tests did you run on your function?
I don't remember.
Okay. So this is one of my comments, right, which you'll hear me say again and again. You got to test your function before you assess it. Okay, part of the goal here is to be able to write a function and validate that it works, which means you want to throw as many test cases at it as you can possibly think of, and then you want to go to your friend and say, hey, how did you test your function? Let me see your test code, right? Not your function that you're trying to write for a grade. Let me see your test cases. Here's mine, let's swap, right? And you want to just exercise the heck out of this thing, every possible case that you can think of. So, edge cases, right? Data is stored in the first node, data is stored in the last node, data is not stored anywhere. Don't initialize your array to zeros, because a lot of times memory has zeros in it already. So load values other than 0. Pick random numbers, right? Make a list with 3 or 4 nodes in it, make a list with a single node in it, make a list with no nodes in it. Try all these different test cases, right? So what was probably happening was I had a test case where the last, let's see, so, this is for the get first, so I probably had a case where, the sentinel was pointing to element 99 in the array, right, and that would have had the data value in it. Yeah, I don't know. It would be easier to speculate if I saw your test cases, but let's see what we were actually testing in that ODP. So. So yeah, I had a test case where the sentinel pointed to element 99, one where it pointed to 3, one where it pointed to element 1, one where it pointed to element 9. But the tests that you did when you just did the T command or you did an A command, there was also one where it found element 99. So it should have worked unless there was a problem in your code and it happened to work on these test cases despite that.
It only, I mean, I did like a few test cases before assessing, and it only missed, I think, like grade 4, I think it only missed that test case out of any of the cases that I used.
Interesting.
When assessing it. And yeah, I was just.
Okay.
I tested, like, I tried to test for edge cases before assessing it, and I thought I covered everything.
Yeah.
But.
Can you come by my office at 2?
Yeah, maybe, I think so.
Are you using a
okay.
loop board? Using a loop board?
I don't have my computer with me, so I don't remember what I put, sorry.
Well, doesn't it be exact while using a loop period?
I think I might have used like a while loop. But I don't remember exactly what comments it was, so.
Okay. Yeah, come by my office and we can take a look at your code and run it through some test cases and see exactly what's happening. If you can't come to my office, shoot me an email to remind me and I'll give you some feedback.
All right, thanks.
All right.
So, I was working on it last night, and I've been emailing you a little bit. You mentioned something like I must have misunderstood what error was. What is error? It looks like an array of integers.
It's a pointer to an integer.
Oh, it's just a pointer.
So yeah, it kind of looks like an array, but you declared it as an array of 100.
Yeah, that's how I interpreted it when I saw it.
Okay.
I must have just missed.
Yeah, so an integer star is a pointer to an integer, right? It's also an array. They're effectively the same thing. But
So that's probably why I was messing up the error when I had it in the main program,
yeah,
because that's how it was declared.
right.
Still confused about. I didn't get a chance to run my function to Gdb since I'll get an email because my classmate.
Okay. We're going to go through some Gdb examples related to ODP 204 in a little bit.
No idea what's going on with that.
Okay. Again, I got office hours at 2. If you want to come by, we can look at it.
Okay, I'll try to.
All right.
So I had a question about, like, after we completed all the functions for PA1, you want us to put it in a Makefile. How would we go about doing that? Like, I'm kind of confused about that.
Okay. So you can have a single file that contains your main program and all of your functions. Okay, you can have 2 files, one that contains your main program, another that contains all your functions. You can have 5 or 6 files, a main program and then a separate file for each function. Doesn't matter. Your Makefile is a series of these statements. There's some target, let's just call it main. And you list the things that are necessary to build main. So main, let's say you're going with 2 files, okay? One that contains your functions, one that contains your main program. So main requires 2 pieces, main.o and functions.o. And if both of those pieces exist and are up to date, then put a tab and write the command for building main. So gcc-o main, main.o, and functions.o. And to build main.o might require main.c. And if main.c exists and is available, then you can say gcc-c main.c. that compiles it into a .o file. And fun.o requires fun.c, and if that exists, you can say gcc-c fun.c. So now you come into your directory and you say make, and it's going to look to see if there's already an executable file named main. And if there is, and if it's more recent than main.o, fun.o, main.c, fun.c, it's done. Doesn't have to do anything. But if main doesn't exist, if nothing exists except the .c files, here's what's going to happen. It's going to say to build main, I need main.o. It's going to look in the directory, it doesn't find it. It's going to look in the Makefile to figure out how to make main.o, and it's going to find a target here, main.o. To build that, I need main.c. It's going to look in the directory, it finds your main.c. That's the only thing it needs. It'll execute this command. So it'll compile main.c with a -c switch, which means I'm not building an executable, I'm building an object. Give me a main.o. Now main.o is satisfied, it moves on, it needs fun.o, same thing happens. Doesn't find it in your directory, finds a formula for it, a recipe, requires fun.c, executes this command. Now it's got fun.o. It pops back up and it says, okay, all the dependencies for main are satisfied. Here's how I build main, and it executes this GCC command, which compiles main.o, fun.o into an executable main, and it's done.
Do you need to build an object file first?
I recommend it. I sent you a big email because I was in a wordy mood when I read your comment. So I sent you a big long email on breaking it into steps. But yeah, that's basically what this is talking about. You don't have to do that, right? It'll work fine. So here's an alternative. Makefile main requires main.c and fun.c, gcc-o main, main.c, fun.c. right? It's a 2-line Makefile, and it will get you to the same place in the end. The problem is, if I change fun.c, it's not only going to recompile fun.c, it's going to recompile main.c. Right? Whereas here, if I change fun.c, the only thing it's going to do is recompile fun.c and then link that with main.o to make an executable. And it's not going to do this again unless main.c changed. So the more you break your project into pieces and the more you write your Makefile like this, the less work it's going to do each time that you build. Now for a program that's a few hundred lines, it's not a noticeable difference. But if you're working on the Linux kernel, for example, and you try to make it by rebuilding everything, it can take you hours, right? Or worse. And if you're only changing one piece of code, you'd rather just recompile that and then link everything together, which is still going to take a long time, but not as long. Someone had their hand up back there.
Yes.
Answered, okay. Have you compiled a Linux kernel recently? I haven't done it in like 20 years.
It's
No.
been a few months, I guess.
How long does it take typically?
I don't know, it's only a couple hours.
Yeah,
But for just like a small change, it's not that long.
Right.
Maybe a minute or two.
okay, cool. Thanks.
If there is a fun.h,
Yes.
how to include it?
So if there's a fun.h and that's included inside main.c, you would add that to the dependencies here. And if it's also included inside fun.c, you could add it to the dependencies here.
There it is.
Yeah.
But you don't need to change the GCC?
But you don't mention the .h in the GCC, right? Because inside your main, for example, you've got stuff somewhere, you've got this include fun.h, which is saying when you're compiling, stop right here, read what's in fun.h and plop that into my file right here, right? Pretend that that's part of my code. And before the compiling actually starts, right, these preprocessor directives, things that start with a number sign, get taken into account. Things that you number sign define will get replaced with what they're defined to be. Things that you number sign include get replaced with, you know, the contents of the file you're including. So by doing this include, all of that code is basically part of main.c. So I would not list fun.h over here on my GCC line. Okay, but this takes us to one of the comments I wanted to make. You don't put executable code inside .h files, typically. You put in things like number sign define. You put in things like struct node curly bracket. What is a struct node? You put in things that need to be said in multiple C programs, but you don't usually put in executable code, functions, things like that. Right? Because if you've got a function, right, I mean, you could just put it right in here. The reason for using an include file is that we have some set of statements that we're going to use again and again in multiple files. And we don't want to type it into every file, and we don't want to have to change it in every file if we make a change. So a typical contents for fun.h might be struct node integer data next valid. And now if I decide I'm going to change what a structure node is, I can change it in fun.h, and since this is being included everywhere, that change effectively takes place in all the files that is being included. And if I change this and I say make, the Makefile will say, oh, I need to rebuild fun.o. It'll recompile, which will pull in the new fun.h and compile. and it'll say I need a new main.o because that's a dependency, which will recompile main.c, which will effectively recompile this new structure definition, and then it'll relink. Alright, so you edit this file, you say make, and you're good to go.
Is there any reason we shouldn't put like the prototypes for all of our functions?
Prototypes go in here also, right? Anything that you want to include in multiple places. But what I've seen people do is make a .h file that contains, you know, get first, the code for get first, and then they include it. And yeah, it makes your program look a little more compact because you don't have all that code for get first, but it's not doing you anything as far as efficiency for makefiles or you know, efficiency if you need to make a change. It's really breaking things into two files, but not in the way that we really want to, right? If you want to break your get first into a separate file, put it in a .c file called getFirst.c and add the appropriate lines to your make file to compile that into an object, and then include that object when you link to get your main program.
And when you include your own .h file, you use the quotations instead of the...
Yeah, if you use quotations, it'll look in your current directory. If you use angle brackets, it'll look in a system directory. Usually it's user include. But if you got a really boss include file, and you got your own Linux system, you can put it under user include if you want, and then you can get it with brackets. Yeah. Other questions? Yeah.
Can I use like star.c or star.l in Makefiles?
I'm gonna guess that it would work, or there's a way to make it work, but I wouldn't do that.
Alright.
Because it's gonna depend a lot on what's in the directory.
Right.
And you'd like the make file to be as sort of guaranteed in its behavior as possible. But you can set up symbols. You can do a lot more with make files than we did in 224, right? We did basically one thing related to make files. You can set up symbols, and maybe you want to sometimes include the -g switch, right? And maybe sometimes you don't. So you can make a symbol called flags and set that equal to -g and include flags in your GCC commands, and when you say make, everything gets included with the -g. Now if you don't want to do that because you're ready for production release, you can set flags equal to nothing and just say make, and it'll recompile everything without that switch. And you can, I mean, make files are insane. They can be huge and complex, and they can invoke other make files, and they can change what other make files do, and it's pretty crazy. All right, so one more comment I wanted to make is related to tar files. So you're submitting a tar file for PA1. So let's say this is your project. So I've got my main, I've got my main.c, and I've got getFirst.c. And you want to bundle this up into a tar file. So a few things, there should be a make file in there also. It's helpful when you make a tar file that you're planning to distribute to other people if you don't have executables and .o files in there. Okay, because typically somebody's going to download your tar file and they're going to say make on their system, and if it's already got an executable, make is likely to say already up to date, nothing to do. But if they try to run that executable on an ARM processor and you compile it on x86, it's not going to run. And the same thing with the .o files, right? Those are dependent on the architecture of the machine. So it can be handy when you make your tar file to only include the .c files, the .h files, right? All the source code that you need to make the executable, the make file itself, and if you were turning in documentation, any documentation files, right? So that's helpful. along the same lines, if you have a clean option in your Makefile, right, and somebody downloads your archive and the executable's already there, then just say make clean and then say make, and that's as good as starting from scratch. So I'm not too worried about those, but those are general comments. Here's one thing that I am a little bit more worried about, though. So if I want to build an archive containing these things, here's what I can do: tar cvf pa1.tar star. Okay, and it creates a tar file containing those 3 pieces of code. And if I do a tar tvf to see the contents of pa1.tar, it shows me get first my main and my main.c. And if I extract that, if I download that and I say tar xvf, it's going to dump those files into my directory. Okay, here's what some people do, is they say tar cvf pa1.tar and then the name of the directory. And when you do that, the archive that's created contains these files as subdirectories of another directory work. And if I do tar tvf pa1.tar, you can see that these things are included in subdirectories. So if I go into a directory and I say tar xvf pa1.tar, it's going to create a subdirectory, whatever your subdirectory was called, and then it's going to dump the files into there. Okay, so what I've asked in PA1 is build your tar file from the directory where your files are, right? Don't dump them in a subdirectory. It's not a deal breaker if you do. I just copy everything out and then I remove the directory and I continue. But I want to make sure you know what the difference is and that you can do it like this, and it makes my job a little easier.
Also, don't name a tar file one of the files you're compressing.
Say again?
Don't name a tar file one of the files you're compressing.
Yeah. So if you make a tar file, it's better to put the tar file in a different directory than the one that you're in. Otherwise, if you say tar cvf star, it'll include the tar file in the tar file. Don't forget to name your tar file, otherwise you lose your first file. How many people here are using GitLab or GitHub? Everybody's hand goes up. All right. Strongly recommend getting on Git. Okay, for the sake of backups, for the sake of tracking your progress, for the sake of being able to go back to previous versions if you think in the middle of the night that you got it figured out and you really didn't. And good general practice, right? Really useful when you're in a job interview or talking to somebody about an internship or something, to not only have experience with Git, but to be able to say, like, here's my Git account, right? There's some repositories up there that are public. You can have a look around and see my work. That's really nice to be able to do, right? But it'll also save your skin late at night. If you do something like tar cvf main.c, which overwrites main.c, and you lose all your work. All right, let's talk about linked lists and ODP. So I got a lot of panic questions last night, and I looked on. I've never seen so many people logged into the server as I did last night. There were probably like 20 people logged on at once. And some of that was the ODP, some of it might have been PA1, but it's good to see people working so hard. So, but I got a lot of questions about the ODP. And again, my first response when someone says I wrote the code, it doesn't work, is show me your test code, okay? And a lot of times we don't have test code, we're just going straight to assess. So how do we write test code for this particular assignment? So the idea was we had a linked list, which may or may not have had at least one data node. So there's the sentinel. We don't care about its data value. If there's a data node, it points to that data node and it's got some value. And this could point somewhere, or it could be my null. Right, so that's one possibility. The other possibility is we had an empty list where this is my null. In this case, if I say get first, it should return 7. So return 7 and error should be equal to 0. In this case, it should return 0 and error should be equal to 1.
So it is returning the data inside of it.
It's returning the data of the first node.
In this case, it's first that.
It's always the first node in the list,
Oh, right.
Yeah.
Never.
but not necessarily
Yeah.
the first in the array.
Yeah, that's right, sorry.
That might have been part of the problem. I think I was interpreting it as an index.
Okay.
But even so, when I did switch it to look for data instead, I would get weird, like those weird numbers, like memory stuff.
Yeah, yeah.
Which may have been like a pointer issue of some sort.
Yeah, maybe you were using the data as an index or something. Maybe something got swapped.
Yeah, I'm not really.
So yeah, let's back up. Does everybody know what we mean when we use the term index? Because I keep using the term index, and we've never gone over that, right? The index of an element in the array is just the location in the array. So this element right here, its index is 3. This element here, its index is 5. Okay, it's the integer that tells you what element in the array it is. So the sentinel is at index 0. Okay, so that's terminology, but if you don't know that, then everything I've said made no sense probably. That might happen anyway, I understand. Okay, so let's look at a possible array for this first linked list. So the sentinel, we don't care what the data value is, so I keep loading 42 in there, just so if we bump into a 42, we can say, hey, maybe we're looking at the sentinel. This is going to be valid. Next is the index of this node with the 7 in it. Well, it could be sitting right here at location 1, or it could be at location 2 or location 3, or anywhere in the array other than index 0. So it could be that next is a 1, and at index 1 we find a data value of 7, and that's going to be valid. And the next field is going to be the index of whatever the next node is, or -1 if there's no next node. Doesn't really matter. We could throw a -1 in there, but we're only working with the first data node so far. Okay, so that's an example of this list. An empty list simply has a next value for the sentinel of -1. And for the sake of that ODP where we're trying to find the data value of the first data node, right, this is all that matters. If this is the index 0 entry, the sentinel's entry, none of the other values in the array matter. If this is what the sentinel looks like and this is what element 1 looks like, none of the other values matter. But it could be that the sentinel pointed to, say, index 3, in which case index 3 has a data value of 7, and it's valid, and we don't really care what the next value is. But this represents exactly the same list of 2 nodes, right? A sentinel node and a single data node, as the values we had before. So if you want to test your getFirst function, what you want to do is create a struct node, right? Define a struct node, create an array of, say, 100 struct nodes, because that's the magic number we were working with is 100, and then set up your data next and valid fields in certain elements in that linked list. If I want my list to look like this, I would say ll_0.data equals 42, ll_0.next equals 3, ll_0.valid equals 1. And then same thing, ll bracket 3 dot data equals 7, etc. And then take that ll and pass it to get first, along with that pointer to the integer that we called error. Come back from the function, see if it returns 7 and set error to 0. And if it did, then it did the right thing in that case. Is there a question on this? Okay. But if error's not getting set, or if it's returning 3, or it's returning something weird, right, you've got a test case now that you can drill down into. Okay, which you can do with GDB, which is what we're about to do. And then test this case, right? Set your linked list entry zeros next to myNull -1 and call get first, and it should return a 0 and set the error to 1. So let's play with this. So here's my get first function, and we'll come back and look at this later, but I've got an error in it. But let's explore it with GDB. So here's my main function. I do include stdio.h because I'm going to do some prints, maybe. If you're not doing prints, you don't need to include it, but it doesn't hurt. I've got my struct node. I would rather have that in a .h file, so that I know that I'm using the same struct node in each file, getFirst.c, main.c. Because if I switch around the order of some of these fields, my code will break. But it'll break silently. It won't tell me that there's a problem. But when it's working internally, it's going to think it's working with the data field, but actually it's working with the next field or something like that. So it would be nice to put those first 3 lines in a .h. I set up myNull to be -1. Just because I asked you to, so I figured I would. And I'm prototyping the getFirst function so that when I call getFirst, it knows what I'm passing, what I'm getting back. And then I'm making myself a linked list. So I declare D to be an array of 100 struct nodes, and I set D0 to be 42. So I'm going to copy this down and then we'll see what it looks like. So we've got data, we've got next, and we've got valid. So what are we doing? D0's data is 42, that's the sentinel magic number. Valid is 1 and next is 7. And then I set D7's data to be 10, next to be 5, and valid is 1. And then I set D5's data to be 20, next is 6, and valid is 1. And I set D6's data to be 50, next is -1, that's myNull, and valid is 1. So what have I set up by assigning those values to the different elements of D? It's a linked list that looks like this. We always start at element 0, that's the sentinel. It's got a data value of 42, and it's pointing to a node. It's not myNull, so it is pointing to a node. And that node is the node stored at index 7, which has a data value of 10. And its next is not null, it's not myNull, so it's pointing somewhere to another node. And that node is stored at index 5. So at index 5 we have a node whose data value is 20, and whose next is still not myNull, so that's pointing to another node, which we've stored in our array at index 6, and at index 6 we have a data value of 50, and the next field there is myNull, which means that's the end of the list. So that series of assignment statements in the beginning of my main.c loads this linked list into the array called D. Now I've got a list, it's sorted, it's got 3 data nodes in it, and I can use this to test my print, test my insert, test my delete, and in this case test my get first, which should return the number 10. Alright, I also have an integer called error, and I'm initializing that to 99. And my goal is to call get first, pass it the address of error, right? So I pass a pointer to my error variable, and I pass it my linked list, and I get back a result. Now why do I initialize error to 99? Because 0 is a very common default value. And if I don't initialize error, it might default to 0, and when I come back and I'm expecting error to be 0 and I look and it is, I'm going to feel really good. Hey, error has the right value. How do I know that it has that value? Because my function set it. So I'm going to initialize it to something crazy like 99, and I'm going to call get first, and if it's supposed to set error to 0, it's got to do that. If it doesn't do that, I'm going to look at error, it's going to be 99. I know, hey, my function didn't actually set it to 0. Okay, so these are the kinds of things that you start to think about when you're writing test code. All right, so I set my error, I call my get first, I get the result, and then I just print it out. And in this case, since I'm printing the first node, which is a 10, this should print out result equals 10, error equals 0. So let's compile this up and let's run it, and it tells me result equals 10 but error equals 99. So I got a problem. So it found the first data node, it found the data value of 10, but it didn't actually set the error. And right there, I'm saying thing pointed to by error is 0. So why isn't it getting set to 0? So let's recompile with a G switch, and let's go into GDB. So we'll GDB my main. And what's the first thing we do in GDB? What's the first command we use? Start. That gets things rolling. So it's about to start executing my main code. If I look at my D array, before I've executed any code, it's filled with all kinds of nonsense. Right? My Sentinel has a data value of -6476, and it points to 32767, and the valid is weird, and so on. I haven't initialized anything. And declaring an array of 100 struct nodes doesn't give you a value for each of those fields in the struct nodes. Okay, it's an uninitialized array. But we have all these if statements, all these assignment statements, which will hopefully give us value. So I'm going to start doing some steps. So I'm going to set D0 data equal to 42. And if I execute that and I look at D, well, that first data value way up on the top shows me that that's equal to 42. But the next field and the valid field are still crazy. So I can next or step. So I can set that, and I can set D0 next equal to 7. And now if I print data, sorry, D, the Sentinel has been set up. Its data is 42, its next is 7, its valid is 1. Right? And that's what we wanted the Sentinel to look like.
What was the command you used to set the data?
The heck is that? To...
Well, because you set it to something different. Okay.
Wow. Don't want that.
We can't wait to see this on YouTube.
Yeah. There we go.
Because you set it to number before you initialized it. But you
So in the code, right, so those are the 3 statements we've executed so far. All I've been doing in GDB is stepping and printing, yeah. Alright, so we executed those 3 statements, which gave us these values in the Sentinel. So we can keep executing. So I'll set up D7's data next invalid, D5's data next invalid, D2's data next invalid, and D6's data next invalid. And now if I print my D array, we can stare at this and it looks a little intimidating, but it's actually pretty easy to follow the linked list at this point. Our Sentinel always starts at 0, and it's followed by the node at index 7. Well, we have to count 0, 1, 2, 3, 4, 5, 6, 7. So this is node 7. And it's got data of 10 next to 5 and valid of 1, which again was exactly what we wanted. Data of 10 next to 5, valid of 1. That's the node that the Sentinel points to. And since it's at index 5, which should have a 20, we can come back here and we can find element 5. So this is element 0, 1, 2, 3, 4. Element 5 is right here. That's got a 20. It's valid. And the next entry is 2. And so on. Now the easier way to do this is just print D bracket 0. And it'll tell you data is 42, next is 7, valid is 1. Next is 7 means that the first data node is stored here at entry 7. Sorry, D bracket 7. And that's got a 10. The next node is stored at entry 5, so we can print D bracket 5. That's a 20. The next node is stored at entry 2, so we can print D bracket 2. That's a 50. Sorry, a 35. The next node is stored at 6, so we can print D bracket 6. That's a 50 and a negative 1. So I skipped one of my nodes when I was building my list on paper. I skipped the 35 somehow. All right, so our linked list looks correct in memory. Okay, each node is pointing to another node and it has the correct values in it, so 10, 20, 35, 50. And the only thing we care about for this particular function we're debugging, get first, is the first data node. We want that 10. So we're at the point where we're setting error equal to 99. If I look at error right now, it's got some crazy value. So let's go ahead and set error. So error is equal to 99. Now we're about to call our get first function. The command you type here is really critical. Say step. If you say next, it will go ahead and it will execute everything inside get first, come back, assign the result to result, and then come back to the debugger. And we're going to miss all the action. So we say step, which is a step into, and that will say stop at the beginning of the get first function. So let's say step. So now we're inside get first, which was called with LL equal to this big long number, error equal to this other big long number, and we're about to execute this if statement. Okay, so I can look at LL bracket 0 with a P statement, and it's exactly the same as D bracket 0. Right? Why? Because arrays are passed by the address of the first element. So LL in here is pointing to the same location in memory that D was pointing to in main. Exact same location. So when I look at LL bracket 0, I'm looking at D bracket 0. And if I change LL bracket 0, I'm changing D bracket 0 in my main. Okay, they're the same locations in memory. So LL bracket 0 has a next field of 7, which is not equal to my null. So this if statement should get skipped. So I'm going to say next, and it's going to skip down, and now it's executing this, setting LL bracket 0 next into the variable index. So I can execute that, and I can print the value of index, and index is 7, which is where the first node is. And now I'm going to return LL bracket 7 dot data, and I can check that value and confirm it's the number 10. That's what we wanted to return. And I can see right here where I'm trying to set error equal to 0. If I look at it right now, it's still 99. But I'm about to execute this return statement. And if I do that, I'm exiting my function. And this statement is never being executed. Why? Because it comes after the return. Return says, get out of here, right? Go back to the caller. And because I set my error after the return, it never got executed. So now, step back into the main function and print the value of error, and it's still 99, right? So this is like playing computer, except you actually got a computer to help you out with it, right? So you've got your code, and you know in your mind what algorithm it's trying to do, but you step through and you make sure that it's doing exactly what you expected. And in this case, right, I'm looking at my code and I see this statement that says star ERR equals 0, and that doesn't get executed, right? You go back and you ask why, and it's like, well, it returned right before. So in 224, when we talk about playing computer, write down the variables on paper and go through line by line, right? Gdb can do that for you, right? It will execute your code one line at a time, and your only task at that point is to see what it's doing and compare it to what you wanted your code to do when you wrote it. And at some point, if it's not working correctly, there's going to be a mismatch, right? And debugging is just trying to find that first mismatch. Okay, it can be a long, cumbersome process, but it gets easier the more you do it. So don't be afraid to embrace GDB in doing this. All right, I'll let you out 60 seconds early. I'll see you next time.